Alright, let's look a little bit about RIP and RIP-NG routing. It's not used often in the modern networks, but you do need to understand how to configure it, just have a basic knowledge of it. Let's use this topology here. We have three routers, we have our different networks, and we're going to install RIP on router 1. In order to do this, the command that you do, go ahead and go into config T. Router RIP puts you into the RIP protocol, and you'll notice that your config line has now changed to config router. In order to turn router RIP off, you would just enter no router RIP. By entering the RIP protocol configuration mode, we're now able to set up the networks that we will use RIP on. Now remember, RIP is considered a classful routing protocol. It's legacy. So to enable RIP routing for the network, you use the network and then the network address. So we've enabled it, and then we put in the network. For this one, we put in 192.168.1.0. That is this network. We've also put in the network 192.168.2.0. That is this network. It has to know about them. Now that we've configured RIP routing, we can do the show IP protocol, and RIP routing is configured on router 1. The values of various timers, the next hop, that information is going to be present. The version of RIP, so we see here routing protocol is RIP. It's sending updates every 30 seconds. The next tells you when the next one is due, tells you when it will be invalid. It gives you the default version, so we're running version 1. It has an automatic network summarization is in effect. It's routing the two networks that we keyed in, and then the routing information sources. We have a gateway, a distance, and the last time it was updated. When we do a show IP route, on this one we told it to begin at the gateways. You see here that these are our RIP. It gives you the network, the gateway, the distance, and the interface. By default, when RIP process is configured on a Cisco router, it's running RIP v1. In order to run RIP v2, you have to tell it that you're wanting to run version 2. So in order to show that you're running version 2, after you do router RIP, you can do version 2. Then when you do the show IP protocols, you'll see that it says that the default version and control is version 2. And keep in mind that version 2 is the classless of the RIP routing. So RIP v1 is classful, RIP v2 is classless. You'll notice that when we go in to show our IP, we see the protocol that we see that automatic network summarization is on. To modify the default for RIP v2 behavior of the automatic summarization, you would have to use the no auto summary router configuration mode in order to turn that off. RIP v2 must be enabled before automatic summarization is disabled. It is not an option with RIP v1. Now, by default with RIP, our updates are forwarded out all RIP enabled interfaces. However, RIP updates really only need to be sent out interfaces connecting to other RIP enabled routers, because remember, your protocols communicate with each other, not with different protocol types. Some of the things that it needs to look at is wasted bandwidth. Bandwidth is used to transport unnecessary updates because RIP updates are either broadcast or multicast. Therefore, switches also forward the updates to all of its ports. You have wasted resources. All devices on the LAN must process the updates to the transport layers, at which point the devices will discard the updates. And there's a security risk. Advertising updates on a broadcast network is a security risk, and RIP updates can be intercepted with packet sniffing software, and your routing updates can be modified and sent back to the router, corrupting the routing table with false metrics that misdirect your traffic. You use the passive interface router configuration command to prevent transmission of routing updates through a router interface. But this still allows for the network to be advertised to other routers. The command stops routing updates out the specific interface. However, the network that specified interface belongs to is still advertised in your routing updates that are sent out the other interfaces. In the topology we're showing here, there's really no need for routers 1, 2, and 3 to send its updates out to the LAN. It's only going to stay within the serial ports here that we need to have them active. So we would use the passive interface commands so that we're not sending information to the routers and to the network so we don't need them to go on. As you'll see here on router 1, we do router RIP, we do passive interface, and then we give it the interface. On this one we gave it the gigabit 00 interface, and then we typed in. That way it's not sending information out of this port here because its LAN doesn't need that information, as we stated earlier. Also remember, if you need to turn that off, you can always do the no passive interface. Putting no in front of a command turns it off. Another thing that we need to look at, similar to the default static route, can be configured with on routers 2 and 3 in this particular topology, but it's much more scalable to enter at one time at the edge route of router 1 and have router 1 propagate it to everybody else. So what we would key in here is a default static route. Here on router 1 we would put in IP route 0.0.0.0, 0.0.0.0, and then we'd give it the exit interface and the next hop command. Here you see this, it's IP route. Here's the quad 0, it's going out of serial interface 001, and then the next hop interface IP address. We've turned on router RIP, and then we have default information originate, which then goes out and populates. Now let's look a little bit about IPv6 with RIP. When we're enabling RIP NG on the IPv6, on this one we're going to use the same topology, and we're going to do it again on router 1. We would do IPv6 unicast routing, and then we would tell it its interface. Then we would say IPv6 RIP, and then RIP-AS enabled, and then exit. And this turns on our RIP interface protocol that we're needing to use. Now, to propagate this, like we did with IPv4, we do need to put in an IPv6 default static route, and it has to be specified. In the example here for router 1, it had an internet connection out of S001, so we would give it the IP address for that interface. And then to propagate it, the default route, router 3, would have to be configured as well here. The IPv6 RIP domain name, default information originate, is the line that you would have to key in at that point. You'll notice that the show IPv6 protocol doesn't give you as much information as show IP protocols did for IPv4. With this one we get the RIP NG routing. It's configured and running on router 1, and that the interface is configured using RIP NG. Now if we do the show IPv6 route command, it displays the routes installed in the routing table, and you'll see those here. And you'll notice that the router 2 LAN is advertised as 2 hops away, and this is because there is a difference in the way RIP v2 and RIP NG calculates the hop counts. With RIP v2 and RIP v1, the metric to the router LAN 2 LAN would be 1 hop, but with the metric for IPv6 it's 2 hops away. Also, when you're doing, if you do the show IPv6 route and then you add RIP, it's just going to show you the RIP routes. It gets a little tongue-tied there, but that's what it shows you.